Thank you all for coming. It's just great to have you here. So today we're going to go over, we're going to talk about Humblefool, right? And talk about why we're doing this event in general. We have a really great AMA with some of our competitive programmers, and we have an algorithmic thinking session with Misof, and then we'll do our winners because everyone wants to know who won, of course. But first, it's important that we talk about the man of the day. Why are we here? And this is because of a man called Humblefool. So many of you might not know him or have never been able to meet him. And that's, okay, because I'm going to let you know about him a little bit. So back long time ago at Tapcoder, Harsha or Humblefool was a Tapcoder member. And he was one of the India's first red-rated coders, right? One of the best competitive programmers to come out of India. And at his time, that was kind of a big deal. And he was able to come to a few Tapcoder events. I got to meet him. It was really great to meet him. And unfortunately, he passed away in a very tragic accident back in 2014. And as always, when something happens to one of our community members here at Tapcoder, we truly care, and we wanted to do something for him and his family. So I organized a single round match algorithm competition in his family's honor, in his honor, and we're able to donate some money to his widow and her family at their time of need. And so it was really tragic to lose Humblefool at that young of an age. He was a really, really awesome guy because he really dedicated himself to helping teach coding in his community. I've heard numerous stories over the years of how he could have had any job at Google, Facebook, Microsoft, wherever, and he chose to stay in India and help teach coders in his region, which I think is really commendable. So that's why we do this in his honor, because he left such a footprint in the competitive programming world. And so this is our 6th annual Humblefool Cup in his honor with the Aparoksha Festival and Triple IT. And so it's been an honor for me to be a part of this year. And I thought it would be more fun to have an event as well, because we don't get to be in person with everybody. We don't get to see each other as much as we want to anymore. And so I'm excited that we have a chance to do this even virtually, to get to meet everybody and honor and celebrate Humblefool. Okay. And it looks like we have Aryan back. So I'm going to bring Aryan up real quick because I want him to say a few words real quick. So welcome, Aryan, to the stage. I don't know if your webcam is able to show. Can we hear you, Aryan? Hello? Aryan, you there? Oh, I think we're having some technical difficulties, so we'll have to come back to him if he's able to join. So what we have up next is we're going to be doing a competitive programming AMA. And I want to show you guys who's going to be here today. So we have brought in Jonathan Irving's, Skynick, and PJ Mathematician. So I'm really excited to bring these guys in. I want them to be able to meet you and share some stories, and we can ask them some questions. So I'm going to bring them up in a second. I'm going to give Aryan one more chance. Hopefully he can come on stage now. Are you there, Aryan? We keep losing him. Okay, we tried. Sorry. Okay, so with that, I'm going to bring up our AMA folks. So folks, come on camera and off mute. I'm looking forward to chatting with you. So welcome. We have Jonathan Irving, a red-rated coder from Singapore. We have Skynick, a yellow-rated coder from Ukraine, and PJ Mathematician, a yellow-rated coder from India. So welcome, everybody. Thanks for being here.
Hey, yeah, thanks.
Awesome to have you. So I thought it'd be a good idea if we do a quick introduction before we get started. Folks, this is an AMA. That means ask me anything. So if you have any questions for these guys, put them in the Q&A tab right at the top of your screen next to chat. There's a Q&A box. So go ahead and put your questions in now, and we'll start bringing them up as they come up. But for now, let's start with you, Jonathan. Why don't you tell us a little bit about yourself?
Sure, yeah. Hi, everyone. I'm excited to be here, meeting you guys all and honoring Humblefool. I'm Jonathan, as Jesse introduced. Yeah, I'm originally actually from Indonesia, but I for the past 8 years or so I've been moving in Singapore, and I officially changed my country in top career, Singapore. Yeah, I started top career about 10 years ago, doing algorithms mostly. So I've been competing in some of the Humblefool Cup as well, and yeah, it's a great round to honor him. Yeah, and probably I should say sorry about my poor chroma key background, because I just realized that my background was too messy. I figure I should chroma key, but yeah, it's a poor chroma key. I apologize for
So
that
it's
part.
easier to have a
Yeah.
virtual background than to clean. I hear you. I bet you many people can relate to that. So thank you for joining us. All right. Nikita, Skynick, why don't you go next?
Hi, so I'm Nikita from Ukraine. I actually know about Topcoder for a really long time, like since 2015, I believe, but haven't participated in many SRMs for a while. I only started somewhat actively taking part in them last year. And yeah, since then I kind of got into it. I know last SRM I got into top 10, which is kind of a big deal for me. Probably not that big of a deal for Jonathan. Yeah, but that was nice.
That's a big deal.
Unfortunately, unfortunately, I don't have much to say about Humbleful because, as you said, I never had the chance to meet him. So that's very sad. I hope we don't lose any further community members in any of the recent events or future events.
Thank you. Okay, PJ Mathematician, you're next.
Hi, I'm PJ, uh, called Poojan, and I'm from Delhi, India, and I'm in my BTech first year, computer science, and I've been with Top Coder since last year, uh, competing in challenges and algorithm competitions. It's really nice to be here and nice to be with you all. Looking forward to your questions.
Awesome. Thank you. And thank you so much, you guys, for spending some time with us today. I know everybody's schedule is really crazy. There's a lot going on in this world, and it's great to get some time from you and share some of your wisdom with our community members here. So thank you. So okay, let's see. If, as I said, if you guys have questions for our team here, go over to the Q&A tab, and we will add them in and go. I see one question about Humblefool. Sure. Humblefool is a top quarter member who passed away tragically in 2014, Shubham. And so we run this event in his honor because he was such a wonderful person in our community. Definitely, if you guys have time, Google search Humblefool. You will find um, lots of awesome articles. And you can just tell with what you read how loved he was because of the way people write about him. So it's pretty incredible. All right. So we do have a question already that came in. That's awesome. So I'll start with the questions that come right in. And I'm put it right on the screen. So graph problems are interesting, but how do we go about debugging problems which fail on specific edge cases and prove the time complexity? So I would answer this because I'm really good at these questions, but I'll let you guys.
Yeah, we believe you, Jesse.
Good. Who wants to take this one? You got a good answer?
I actually have one thought that I just was thinking yesterday, if you don't mind. So when debugging, sometimes we do things like stress testing, where you generate a lot of small random tests and try to check against some naive solution if your solution outputs the same thing. So one interesting problem that you can work on yourself is how to generate a random tree. So there are many possible trees. Perhaps you know how many of them there are, and you may be wondering how do I generate random trees so that all possible trees are equally likely. So I believe Jonathan already knows the answer, but it may be actually somewhat unexpected that you can't do something naively, let's say loop through all the vertices in order and connect to parent for connect vertex v to some random parent between 0 and v minus 1. I believe this does not work, but there are ways to generate them uniformly. So that's a fun little tricky problem to think about. So yeah, but to answer the question, usually we do some stress testing, try to come up with a small test case that we can dry run. So like just write down on paper what happens, how our algorithm works compared with how we expected it to work, and so we debug. The question about time complexity is obviously more like involved because it's very specific to the problem. Which time complexity you are trying to prove, it will involve different techniques. So I won't get too deeply into it.
Awesome.
Yeah, I guess for me, when debugging, yeah, and don't blame yourself when you submit a solution and got wrong answer and you need to debug it, because even like experts encounter it as well. And yeah, I guess there are two kind of debugging. One where you don't actually know what's the input that you're wrong on, and the second one is where you actually have a sample input that you're wrong on. It might be a sample test case, or you might figure out what's the input by trial and error, let's say. Yeah, the second one is usually easier because you have the input that you know it's wrong, and you can print out variables in your code so that you can trace each line by line, try to figure out why your code is wrong in this input. But the first one is harder because you don't even know why it's wrong. You don't even know which line is buggy, and you don't even know like what what is the input that you're wrong on. And yeah, it's a tricky one. And yeah, and sometimes when you are when you look at the code and you can't find it, then yeah, sometimes we need to write another solutions that is slower but we know it's correct, and try to generate many random test cases. And again, some problems might not be easy as Kai mentioned, but yeah, I think there are various ways to do it, and then run it with your slower solution and compare it with your faster one, and check whether there is difference. Yeah, again, even like experts, like I think Top Coder Open is a good contest because in the finals they broadcast these screens of all the finalists, so you can even see that experts finalists do that, like write slower solutions and find generate many random test cases, and you can also see how they generate it. And yeah, even experts do that. So yeah, sometimes that is necessary if you just can't find what's the counter test case of your solution. Just generate random solutions, produce the correct output from your slow solution, and compare it with your solution.
Awesome. Great advice. Does that help you, Raul? Hopefully that was a good thing, a good response. Thank you, guys. Okay, so I want to go. I have a question for you guys. I want to start with this. Is why are you a competitive programmer? What brought you to competitive programming? Because I know for me, it's not something I've ever done myself, right? But what brought you to this? So I'd love to hear from you. So why don't you, PJ Mathematician, start? Can you hear me, Pujan? Or is he frozen? Oh,
Kind
there
of
you are.
slowly and gradually I into hello, can you hear you? Can
There
you hear
you
me?
are. Okay, we were just asking you what brought you to competitive programming.
I can. Yeah. So yeah. So initially I was interested in mathematics, but then slowly I started with competitive programming, uh, the and gradually I started with doing and exploring various algorithms, and then I just fully committed myself to competitive programming, and just I am doing them parallelly. So that's all.
Awesome. What about you, Jonathan?
Yeah, I guess my story is similar as well. That I started mathematics even in very young, like primary school. I think most of us do that. And yeah, but I wasn't very successful at that. So at high school, actually, I moved to informatics because in back in Indonesia we can only choose one competition, like one track. So I feel like yeah, mathematics is too hard, and the people are there are very good. So I moved to informatics, and yeah, and managed to get some success there. And but yeah, I still do it even until now. Like not just doing competitions in primary schools and in high schools and universities. Even after that, I still just do it for hobby basically. Like it's interesting, and yeah, it teaches us to think. It challenges us on problem solving, and yeah, it's fun.
Awesome. Love that. What about you, Skynick?
Yeah, I also started with math. I actually was a little bit more successful. I went to International Math Olympiad in 2016 in Hong Kong, got the silver medal there. But then college started, and kind of math competitions, or at least in our region, math competitions kind of end when you graduate from high school. So I started doing some programming because it was very closely related. A lot of programming problems, especially ad hoc problems, are kind of just math, and then you have some small nice implementation. So yeah, it's all problem solving. It's very interesting to solve some puzzles. I don't know, just something that you want to. I mean, you feel good when you solve some problem, right? That's always nice.
Yeah, that's great. And it's like you want to be passionate about what the things that you like to do in your free time and have fun. And if that's something you like having fun, that competitive programming is a great fit. So that's very cool. Um, all right. So some really great questions have come in as well. So how do you manage your time if you have a full time job and you like to do competitive programming? How do you balance that? Or if you're a full time student, I guess, as well. So how much time do you spend on competitive programming? Who wants to start with that one? Jonathan, go ahead.
Yeah, I guess it's a tricky question. Yeah, I don't think I spend that much time these days because of work. I used to do it more when I was in college. If you ask me the hours, um, I don't know, maybe like 2 hours every week or something. And especially if there's contest on the weekend, I usually can still join them. But yeah, on weekdays it's more challenging to me. And a good thing about Top Coder SRM is that it's short. Even Top Coder open rounds as well, except the finals maybe. The rounds are short. It's like just 1.5 hours total with all the challenge phase. So yeah, it's I think contests in other online judges. Which I don't know I can mention, but yeah, yeah, they usually have 2 hours or even longer. So yeah, actually, for me, that I also find it hard to find free time. So yeah, Top Code is actually quite appealing in that sense. But yeah, I try to do contests whenever I can, and that turns out to be like 2 or 3 hours per week usually.
What about you, Pujan? Pujan, what about you?
So I am a college student, so I do have free time, and I can so I yeah, so I have free time that I can spare to uh, for coding and competitive programming. So mostly I spend my time practicing questions, and I compete in around 2 to 3 competitions per week. So I think 7 to 8 hours per week I can manage with my along with my studies, but I do decrease my participation when near. So it's kind of
Yeah. What about you, Skynick?
Okay, so I only have a part-time job, so it's somewhat easier. In my I am like in the last year of my master's degree, so I'm mostly just writing my thesis right now, so don't have that much class hours. So I guess for me it's easy to like participate in whatever competition I want. But if you are constrained with times, then I would say pick one or maybe two different platforms, preferably pick Topcoder because of the reasons Jonathan explained. And yeah, you most likely you can manage like one or 2 contests per week, that's already very good to keep your brain working.
Yeah.
I mean, if
Um,
you can't forget puzzle solving once, like completely. So if you learn some algorithms, you will remember them, and then occasionally seeing new ideas is good enough to keep you well practiced.
yeah, yeah. That leads right into the other question I was going to have, kind of similar to the one that we have in um, the chat, how to stay motivated, right? So I'm assuming, with anybody who has a hobby or passions, if you stop for a little while, maybe you get a little rusty, right? If you stop playing tennis or something, maybe a little rusty, a little sore if you come back to it. So what about you guys? How do you stay motivated? And if you do take time off, does that affect you? And how can you, overcome that basically? Pujan, why don't you start with that one?
Yeah, so I keep myself uh, active in competitive programming by solving at least 2 to 3 questions in every topic, like some questions in graphs or trees, or basically any random questions. And you can easily find loads of questions on the internet. And if I have any busy time, or there's some kind of a break from competitive programming, it I agree that it takes a while to get back into it, but uh, you can get ready for, you should be kind of prepared for a setback from the ranks, and the going to challenges, you should be back in the form.
What about you, Skynick?
Yeah, so motivation was never really a problem for me because, as I said, I do it because problem solving is fun. But I know that a lot of people do it for like to get better prepared for job interviews, for example. I think it's a good way, but you need to balance. Like you probably don't want to go very deeply into things like, I don't know, matrix multiplication on segment trees. I just last problem I solved. You probably don't need that for interviews. So yeah, if you want to do it to get your job, then it will be helpful, but don't push yourself too hard. You probably will learn the important stuff just by practicing a little bit. So that kind of helps you keep the motivation. Just by a little bit of consistency every day will get you a long way. But coming back after a break, I actually, if you look at some of my graphs, rating graphs on other platforms, then you will see that I have long breaks when I don't really do competitive programming because other stuff in life. And every time I come back to it, I feel a little bit rusty for a few first contests. So I usually try not to jump back into like important events straight away. So if there's like Div 1 round, then I try to do something easy before to just make sure that my I don't know typing speed setup is up to date. Maybe you can do some like lead code contest, which is super easy just to
Mm-hmm.
get you started before important events like single round matches.
Cool, good advice. Yeah, for sure. And to be fair, we are a love all community here at Top Coder. So wherever you're doing your competitive programming, I think that's great because it's helping you to improve and grow your passion. So yeah, we work with all the other platforms and we love that. What about you, Jonathan?
Yeah, I guess my answer also similar. So yeah, uh, I I guess I just yeah again I find it fun. So I think Sky also mentioned as well that it's not really a problem for finding motivation because I just enjoy it. Yeah, one thing that I guess I can add is that in uh, back in the early days when I started this, I have a friend that is also started doing this, and we both kind of like competitive person, and we use our ratings as metrics, as a metric. Yeah, that can be quite motivation as well sometimes to get better than your rival. Or yeah, so maybe sometimes you can find a person that a friend that you can study with or even compete with, and sometimes being behind ratings might motivate you.
Yeah, for sure. Awesome. Thank you for sharing. I think that's really helpful tips and advice for everybody. So thank you for that great question. All right. We have a question about heuristic contests. Do you guys have any um, feedback or help for some suggestions for someone interested in those?
Yeah, I never competed in marathon myself. I competed in some heuristic contests on other platform, but I'm very bad at it, so I probably shouldn't say anything.
That's great. Anyone else have any tips on that? All right, I think that is a great question, Ultra Instinct, to go and put in Top Coder Discord, because I guarantee you there's a number of Top Coder members who would jump on the chance to help with that question. Thank you so much. All right, we have another one. This is a great question from Guarav, actually. Any tips to be able to quickly challenge the solutions during the challenge phase? Who has any tips? Or you're not going to share your secrets? Not too many of them.
Well, probably it helps if you already have written some tests for your solution, so you know what may be tricky for other solutions. But also, like, just looking for unusual things on the scoreboard, like if somebody took really long time to solve some problem, maybe they just didn't come up with the correct approach and tried something heuristic instead. So I always try to watch out for unusual scoreboard patterns and stuff like that. And yeah, preparing tests for your solutions means that you can use them afterwards for challenge phase on someone else.
Yeah, I guess the other way around as well, right? You mentioned some people that takes longer than necessary to solve the task. The other way around is also true, where the score is unusually high. That might also means that the person was like their solution is too simple. They yeah, so that yeah, basically any unusual score might be a sign that the solution is incorrect.
Or it could also be a strategy that they're purposely making it go long so that you are tricked. Oh, those mind games you guys like to play. It's fun. What about you, Pujan? Any other advice there?
Look, like I agree with them, and I also mostly look out for the submission times, basically, and yeah. So I do not have anything new to add.
Awesome. Um, great question. So from Cats, how do you guys keep yourself from getting into new technologies, such as machine learning, deep learning, and competing in those types of challenges? Um, any of you guys have any interest in that, or how do you not have interest in that? Not interested? No.
Well, I can say just a little bit. So I kind of have work
So I have
experience in
some
machine
kind of
learning.
interest in that.
Oh, sorry. There's
So
a
like, uh, I basically I learned I basically learned from the challenges that are posted on Top Coder.
Did we lose you, Pujan? Yeah, it looks like we lost him for a second. So I'm sorry, Skynet, go ahead and finish your thought there.
Awesome. So as I was saying, I have some work experience in machine learning. It didn't really work out well, so it was like back in 2018. We tried some new methods. They didn't really work. So we rolled back to plain old statistical analysis. And kind of since that time, I'm not really interested in machine learning. Maybe I need to see some new applications to believe more in that kind of stuff. But yeah, for now, I mostly prefer doing, I don't know, just standard algorithms. Or not standard, but like algorithms that you can prove that will work the way you expect them.
Hmm.
So yeah.
Awesome. And apologies there. I think there's a little delay on Pujan's end. Let's move some issues there. So, a few more questions. Ultra Instinct. I love this. I'm not going to be greedy and get how you guys are so good, but can you share your views about providing a greedy solution uh, during or after a contest?
Yeah, I think we need to be honest that we submitted some solutions that we didn't prove to be correct. And again, even experts do that. If you see some posts on forums that are even right coders that that say that as well. Yeah. So yeah. Well, again, I guess it's fine. Yeah. Well, maybe depending on your purpose why you are doing programming contest. If you're trying to be a theoretical person, then probably it's better to prove. But I don't think many people compete in programming contests to do that. If you want to be more theoretical person, then people will go to math contest. Uh, but yeah, yeah. So yeah, and I think yeah, looking back at the scoreboard, seeing like submission times again can help you in like when you see a greedy problem that the greedy solution seems to be intuitive and quite easy but you're not sure. Yeah, we can take a look at the scoreboard, and if crack coders do submit in fast time, then probably it's correct. Well, it's not guaranteed, but yeah, it's some indication that it might be correct. So, and yeah, of course, if you want more practice, you can prove it after the contest. But yeah, usually when I compete during the contest, I don't really care about rigorous proof. I just if I believe enough that it's correct, I just got it.
Confidence matters, right?
Yeah.
Do you prepare tricky tests during coding phase itself and quickly try it on the submissions based on the high level idea of code? What do you think, Skynick?
I really remember one case when I came up with a test case like specific for the solution that I saw. Like after examining the specific implementation very carefully, but it was just like some weird typo. So majority of time for me, the test case fails some solution because the general idea is incorrect. And yes, this like type of test you can think in advance. Like think about your ideas that failed during the coding phase and try to fail them. So yeah, majority of time I will have good tests ready before the challenge phase. And very rarely I will spot a specific mistake in some specific submission during the challenge phase. Because, even if you do, like, what about if somebody else opened this submission faster and already like found the test case? That happened to me when somebody outpaced me to challenge a solution. So yeah, it's really hard to design a test case during a short challenge phase, and most of the times they are prepared beforehand. At least for me.
Mm-hmm.
Maybe guys have
Yeah,
other.
yeah, I guess especially if you are stuck with solving the problems during coding phase itself, you can spend the rest of the time preparing tricky questions. Yeah, the 5 minutes intermission might not be enough as well. So yeah, if you have time during coding phase, you don't know what else to code on, you can prepare some. And actually, yeah, I think the question mentioned high level idea of code. I actually even like sometimes try to copy the code. I think yeah, Misoft maybe later can correct me if I'm wrong and don't disqualify me if it turns out that I'm wrong. But I've been copying solutions using manual retyping. If I understand correctly, the rules is using OCR is not allowed, but manually retype the code is allowed, because the code you can't copy paste because I think they convert it to image, but you can actually retype it. That's what I understand the rules, at least. So yeah, yeah, and this is maybe why you should join the typing club in Discord and practice your typing speed, yeah, so that you can retype other people codes faster. I probably, every time I do this, I need like 2 to 3 minutes to copy like 50 line solutions or even 100 line solutions. So yeah, sometimes when I just not sure whether this will actually fail my tricky case or not, I retype their solution.
So great plug for the Typing Club. I love it. And I
Yep.
know the Typing Club is in Discord if you've not heard of this yet. And I know that Jonathan, you're a whiz in there, kicking everybody's butts all the time. So if you want to improve your typing, join the Dark Haze Typing Club in Discord, guys. Thanks
I
for
got kicked
sharing
out
about that.
earlier today.
Yeah.
Yeah.
Yeah. I don't join because I like to win and I'm not going to win yet. So I need to get better first so then I can join and then I will win. So the second part to Gaurav's question is also uh, do you first read other solution completely and then try to think of tests? And I think you kind of answered that a little bit. PJ, you're back. Do you have anything to add to this? I know you've been losing a little bit of bandwidth here and there.
Yeah, so like I was listening to the answers and I agree 100%. Uh, like they covered all the points.
Awesome. Glad to have you back.
Thank you.
um, how effective is teaching algorithms techniques in clarifying our own concepts regarding the same? That's a great question, Warl. You
Well,
want to jump
I
in?
have never.
Okay.
Oh, sorry. Yeah, let's hear from PJ because we've been losing him a lot recently.
PJ, you want to take this question?
Yeah, so I also teach and try to take tutorials for my classmates, teaching them like they always ask me questions and questions from competitions, and many times. So there are both. Sometimes I can solve, sometimes I can't. But it does help to teach and share the concepts that we know to others, and that at least that helps me a lot to clarify my own concepts. Yes.
What did you have to add to that, Nikita?
Well, I never taught algorithms myself. I only taught like math, and that helped me with some tricky topics like combinatorial null or stuff like that, which I didn't understand first time, but then after I taught some people on it, I kind of got better at it. So yeah, I would imagine the same kind of thing goes with programming and algorithms. So yeah, if you have a group of people, definitely you can help yourself and you can help them. So that's very great if you have time and you want to teach people and you have something to teach them, definitely do that. It's very welcomed in the community. Your students will remember you. I don't know, it's just a great experience for all parties.
Yeah, for sure. Awesome. So, all right, I have a question, you guys. We've been talking a lot about obviously competitive programming. That's what this is all about. So I want to ask something fun, and this has actually been a really fun forum thread back in the old days of Tab Quarter. But what the craziest SRM story you have? So we've had members who have skipped dates to go to compete in SRM. We've had some try to do them on the train, and lots of different places. So, do you guys have any fun SRM stories, like trying to get to that computer or anything? Who's got one?
For SRM, the most memorable that I can think of is I did it in a school canteen, high school cafe. Yeah, because it's the timing was just after my high school class finished. Yeah, so I think that's one of the, like, if you ask me, like the craziest place that I've been SRMing at. yeah, I did another contest in on board of a plane, like live. Yeah, unfortunately they have Wi-Fi, and it's a long flight, like I think from Singapore to US or something like that. It's 10 hours flight, and I have nothing to do as well. So I just there's a contest during that time, so I just did. Unfortunately, it's not top coder, so yeah. But for top coder, I think it's the high school one.
Awesome. No, that's cool. Like, if there's a programming contest on a plane, that's perfect. Hey, next time you guys have a long flight, let me know. I'll check the calendar, see if I can schedule one for you. Anybody else? You guys have any other good stories? Whatever programming contest you guys had to do that was a little different. Nothing yet? Well, if you don't have one, you're gonna have to plan one. So awesome. Good question from Penna. How do you weigh time spent studying algorithms and theory against solving problems and practicing? So I guess how much are you looking at practicing versus actually going and doing it and studying? Who wants to take that one first?
Yeah, maybe. Yeah, for me, yeah, again, because of my commitment with work, I these days I haven't really had time to study algorithms. There are, yeah, I think there are good forums in that platform and in Topcoder as well, that people just post algorithms, new algorithms. Yeah, even like even like if you ask like even experts like 3 years ago, even like tourists, let's say, like 3 or 4 years ago, he probably didn't know about it as well. Like it's completely new. People are posting many great new stuff. Yeah, but I just don't have time to learn about it yet, to read about it yet. So I mostly solving problems. The one that I mentioned, every time there's a contest on the weekend, I try to solve them. But yeah, let's say there's a problem that I can't solve and it requires this algorithm. Sometimes I take a look and read them. But if I just want to just study new algorithms, I actually don't know what to read them because there's so many of them, and I don't have time to read all of them. So I just do contests, and sometimes if I, oh, these problems actually requires this technique, sometimes I read them. Oh, then I learn about it.
Awesome. Um, That's cool to know. And I think then the other question that we have that's getting a lot of votes is competitive programming or a girlfriend. So, which is really funny. As I was saying, there was a time when people were skipping dates for SRM. So, I guess the question's on you. If you have a significant other, are they do they care about your CP habit? Are they supportive? Do they get irritated with you? Like any advice for folks in a relationship?
Is this going to be broadcasted to public?
We promise not to share with your significant other. I promise. So clearly, you guys are all mum, like not saying a word. Don't blame you. Um, okay, there you have it, guys. The best rule of thumb is to not say a word about it. All right, that's the advice given. Oh, I'm just going to the store to run some errands. No big deal. I'm just taking my laptop in case. Meanwhile, all good. Love it. Um, all right. So, how to be invited to a top quarter stream? Oh, Warhol, just let me know. You want to come and join an event? I'll invite you. No problem. So it looks like we have about 8 minutes left, and then we're gonna have the amazing Nisaf come in. So let's take this question Penna has and make it a little deeper. So right now, you guys are competitive programmers. You do your thing. You're passionate about it. So what are your goals with it? But also, what advice do you have for somebody else? So why don't you each take that question, and then and we'll see what kind of tips and advice you guys can give to everybody. You want to start, Skynick?
Well, as you introduced me as the yellow coder and Jonathan as a red coder, I believe target at some point. So obviously I'm not good enough for target, but yeah, to become red on top coder would be a great achievement. I think it's a little bit easier nowadays than it was back in the day. So definitely like achievements of people like Humblefool are much more significant than becoming red now because the community have grown. Just rating inflation happens. So yeah, that would be great. In terms of advice, I think it's the proper advice, like I've heard that this quote that like the worst vice is advice, right? So I think to give a proper advice that will work for all people is just too hard. But if you have, like, if you want me or Jonathan or anyone else to consider your specific case, then join Top Coder Discord, ping us, and we'll be able to respond.
Awesome. Thank you. What about you, Pujan?
Can I? Can you hear me?
Yeah.
Okay. Okay. So yeah. So like do have some great plans in competitive programming. I'm all like I just started it last year, but I am really enjoying it, and I think I might go into teaching and tutorials along with some kind of basic work. So my current goal is teaching and tutorials for competitive programming and questions.
Awesome. And any advice? So, yeah, I know you're newer, but what advice do you have for someone just starting out? Did we lose you, Pujan? Um, all right, I guess, Jonathan, what about you?
Yeah, so yeah, I think Sky mentioned about becoming target at one point. Yeah, that's one of my goal. I guess the other goal is, of course, to be at TCO finals. I actually haven't been
Yeah.
there. Yeah, and any other. I think there are many yearly programming contests as well. Google has it, and some other platforms as well. Yeah, I wish to be in one of these finals. I've never been to on-site finals before. Yeah, and actually, yeah, if that happen, I might not be as active as current anymore, because yeah, I find that the one that I just mentioned is like one of my goals since I started this, and I thought to myself that I won't stop practicing until I achieve that. So yeah, that's one of the goals. Yeah, especially in, I don't know, in other countries, but in Indonesia, in Singapore, in Southeast Asia, people don't really do this a lot after college. Like they do ICPC in college, but after college, yeah, especially because many people in this region don't continue study, like they go to industry instead of academic, and in industry you probably don't really have flexible timings with work. So many people here don't actually active in competing after college. So yeah, many people ask me why I'm still doing it, and yeah, that's my answer. Like I'm still trying to be target or be in any of these finals. So that's my hope. And about like advice for newer programmers, newer contestants, yeah, I guess I mentioned it earlier that yeah, maybe if you're hard to find motivation, try to find your friend that you can study together, and sometimes being behind rating might motivate you. So and not just for that, but sometimes you can ask your friend questions as well. If they can solve some problem but you cannot, you can ask him or her how to solve that. And yeah, I think it's a great way to find uh, friends, or yeah, to start to practice together.
Absolutely. Yeah, that's great advice. And I think one of the things that is amazing is we have a competitive programming community, right? And it's overlapping across lots of different platforms. And so I've found that many of the competitive programmers that I've interacted with are very welcoming and helpful. You guys have a really great rapport with each other. So, being a part of the Top Coder community and participating in challenges everywhere and connecting with other people is a great way to improve your skills as well. So definitely join our Discord channel. I think my teammate shared it in the chat. And just every contest that you see, try to participate in it. Right, whatever contest it is, the more you participate, the better you do. And I know that's really what a lot of our other competitive programmers say as well. So awesome. So those were amazing questions. And this was a really, really great AMA. I want to thank each of you for being here today. There was a lot of difficulty in having our AMA set up for today. And these guys came in and really nailed it. So I really appreciate it. Thank you so much, Jonathan and Pujan and Nikita. We really appreciate you being here and being a part of our Top Coder community, of course. You guys are awesome. And I can't wait to see you at the TCO finals because I know you guys are going to make it someday. So I'm looking forward to meeting you. And we'll toast and have a fun time together.
Yep. Thanks for having us here, Jesse.
Thank you so
Yes,
much.
of course. Thank you. All right, everybody. Thank you so much. So now we are going to move on to the next part of our event. Um, we have a special guest here by the handle of Misaf, which you probably know. I've met Misaf a number of times, and I can promise you he's much taller than me. Because I know that's one of the one of the things going back in the day, how tall Misaf really is. He's tall. He's much taller than me. Granted, it doesn't take much to be taller than me. That's the joke for the day, I guess. If you've ever met me, super, super short. But anyway, I'm so glad to have Misaf coming in today. I'm going to bring him up on stage, and he is going to give you a talk on algorithmic thinking. And so, Misaf, we're so happy to have you. Thank you for being here. And I'll let you take it away.
Hello, Jesse. Hello, everybody. I'm very happy to be here and to have the opportunity to talk to you about algorithmic thinking. So let me just share my screen with the slides and we can get straight to it. So if everything went well, you should now see a slide that says algorithmic thinking, and I will be then talking to you about this topic. Yeah, looks like we are all set and ready to go. So here's a brief overview. This is me. I used to compete back in the day. I ended my high school years in 88, 98, 99 and competed at IOI, IMO. And since then, I've done everything as a contestant, as an organizer. I've been around for over 20 years, setting problems for various competitions. Nowadays, I'm the algorithm coordinator for Top Coder, writing books, puzzles, and so on. So I'm very much interested in talking about algorithms, algorithmic thinking, thinking about how to teach algorithms. And today I will talk to you about, I will give you some of my views on algorithmic thinking in general, what it is, how we think, how our heads operate, how we learn to think, and how we learn to solve problems, how it's all, at least in my opinion, interconnected. And then for the rest of the talk, I will show you some cute algorithmic puzzles that are kind of related to the topic, and I will talk about them and why I like them and what makes them interesting. So the first thing we are going to do is talk about thinking, in particular algorithmic thinking. And one big picture overview is that we happen to be doing in a field where everything changes every year. Like mathematics has been roughly the same 300 years ago. Biology has, I mean, all of the fields are making progress. They are making new publications. There's new science, but very rarely something changes so fundamentally than it does in computer science, in the IT, information technology, all these areas. The older among us still remember ages when we had no phones at all. The only telephone was an actual phone line that was connected to the phone network. We didn't have any mobile phones. Then in a few years, we came through mobile phones that were barely able to make calls and send text messages to the modern phones that we have nowadays, which are each and every single one of our cell phones today is more powerful in terms of computing power than all of the equipment that were used for the first moon mission, for example. So we currently have amazing hardware, we have access to the internet and so on, and everything changes so quickly. So if we are trying to have a career in either the scientific parts of computer science or just as a software developer in IT, we cannot just learn something and then expect that for the rest of our lives we will be doing it. What we need to do is we need to be constantly trying to improve ourselves, follow what's going on, find the new trends and learn new stuff every day. So if you want to be successful in these areas, the main thing you need to do is not to learn, you need to learn how to learn efficiently. And one thing that can help you really significantly doing this is understanding concepts. Let me illustrate what I mean. In our area, in programming, and this is the example I have here on the slide, it's very common for novices who are coming to the field to come and ask questions like, I want to learn how to implement the game engine in Python. This is a legitimate question. You will find it asked all over internet. But nobody goes to a driving school and asks, I want to learn how to make left turns in Nissan Micra. It sounds ridiculous, right? And these two questions are much closer to each other than novice would think at a first glance. You cannot, well, you can, but it's very similar. You can learn how to make left turns in an Nissan Micra, and on the same extent, you can like follow an online course or something and learn some basics of how to implement the game engine in Python. But similarly to being a proficient driver, being a good software developer does mean that you don't need to learn the specifics of a technology. You don't need to learn the specifics of one particular use of the technology. What is important are the concepts. When you're learning how to drive, you're learning how to read the traffic around you, how to follow the traffic signs, how to control your car in general. And all of the important concepts, all of the things you are trying to automate inside your head, will remain the same when you sit in a different car and when you go to a different location. And the same should be correct for the way we are learning to interact with the IT world. We shouldn't focus on technologies because the technology of today will be gone in 2 or 3 years. We should focus on the concepts, on the stuff, the ideas behind it, the ideas that remain still the same, and that will help us grasp the new technologies quickly and efficiently when they come. So this is how learning in IT works, in my opinion. And now let's move on to the actual topic of the talk. What is algorithmic thinking? And this is something I think that in the 21st century, in the modern world, everybody needs some aspects of algorithmic thinking in their lives, and it can make their lives more efficient and better in many senses. And this is not just about being a software developer and using algorithmic thinking about when you are doing your job, but this also connects to our everyday life. And as we will see on the next slides in some examples I have prepared. And this is also the main thing people want to see when you are doing interviews for software companies. If you have a smart interviewer, a person who knows how to evaluate people who are trying to find a new job as software developers, this is the main reason why they are using these algorithmic puzzles as interview questions, because what they want to see is two major things. One of them is how you think, and the other is how you are able to communicate your thoughts. So the purpose of these algorithmic puzzles that are very popularly asked as interview questions isn't actually solving the puzzle or not. The main purpose is showing your progress, showing the way you think, how you approach the problem, how you analyze it, how you think about corner cases and so on, and also whether you can clearly communicate these thoughts to another person. And this isn't something special where you have to be born with a special talent and otherwise it's inaccessible. This is just a skill like any other. This is like juggling. Everybody can learn to juggle. Somebody will be better, somebody will be worse. Talent is kind of the inherent limitation, how far you can get and maybe how quickly you can get there. But anyone can practice, anyone can improve, and this is also true for algorithmic thinking. So when you are preparing for interviews, instead of cramming specific algorithmic puzzles you have seen used as interview questions, a better use of your time is focusing on the ideas behind them, on the concepts, on the techniques, how these problems can be solved. Because if you are given a puzzle you haven't seen, which should be hopefully the case in most good interviews, you still have to be able to applied solving techniques instead of just rattling off from memory a solution you have seen somewhere. A good interviewer will not be fooled by you rattling off a solution you memorized, because they will ask you additional questions and suddenly they see whether or not you actually understand the problem you're trying to solve. So, what is this algorithmic thinking I'm talking about? There are many different aspects to it. Three main parts I will talk about is modeling and planning, abstraction, automatization. So, modeling and planning, first exercise for everybody at home. Imagine a route you frequently travel. For example, if you are going from to schools, or you are working not from home but in an office, imagine your route one way or the other and try to think about details. Are you crossing a road somewhere? If you are driving a car, are there multiple options you can choose? How do you choose which way to go? If you are going through some specific locations, is there something you need to be careful about, and so on and so on. And each and every one of us can visualize very, very many of these tiny details for routes where we frequently travel. What we are doing now is building a model in our head, and we can also use this model, once we have it, to do the planning. For example, imagine you have two options that take you to your destination and they go through different locations. You prefer option one, but now you get a message that there has been a traffic accident and option one is blocked. What do you have to change? Where will you switch from option one to option two? How will your path adapt? If both of the options are blocked, what will you do then? And now you are going to a bigger mental model of the city where you travel, and you are thinking about other possibilities, how to go around both sides. And so this is modeling, this is planning. Here's another example you can do as an exercise at home. Completely without looking, try telling me how many windows are there in your entire apartment, especially a good exercise if it has more than one room. Most of us should be able to think about the individual rooms, imagine them, visualize what the windows look like, and so on. Extra question, how do those windows open? And yeah, most of us should be able to do this, to answer these questions without actually looking, without getting up from our seats, simply because we have already the mental model of our apartment in our head. We live there, we interact with these objects every day. So more or less successfully, we should be able to work with all of these concepts in our head. Yeah, so this is something that happens both in real life and when designing software. In real life, when you are organizing large events and you have to think about many different aspects, where you have to book a location, when you have to tell people to be somewhere, organize transport, and so on and so on. If you are going to shop at a large store, you want to buy different things, it pays off to think about the list, to shop in correct order so that you are not going back and forth, picking up stuff and so on. A general strategy to life about like saving, investing money you make every month is also an example of modeling and planning. And these are the things we also do much more significantly when we are working, for example, as software developers. When modeling, when planning, we are thinking about what parts does our software have, how it can be decomposed into components, into modules, how do those modules interact, what do we have to keep in mind, all kinds of preconditions, post-conditions. For my module, I'm expecting that it has to have input in some specific form, and if that is guaranteed, I will then guarantee that the output will have this and that property. When I'm implementing a binary search, I have to think about an invariant for the lower bound, for the upper bound. The lower bound is always less than or equal than the answer. The upper bound is always strictly greater, and so on. When I look into the middle, I have to make a decision that preserves this invariant. And one of the very important lessons from all of this is the significant difference between IT people and pure managers, because a pure manager will very happily do something like in the middle of the afternoon, schedule a 10-minute meeting for all hands. Everybody has to take part. And the manager is like, it's only 10 minutes. it doesn't take anyone much time. But here's the problem. When we are working on software, we have to build these mental models in our heads. We have to keep all of the interactions more or less active, think about them, focus on them. And doing this takes a lot of time. And if you are interrupted, if only for 10 minutes, it means that you can start from scratch. So it turns out that an innocent 10-minute meeting usually has a much, much bigger impact on the productivity of software people, and this is why they are so universally hated by everybody. So if you happen to know some peer managers, talk to them about this and explain to them that the interruption is much, much bigger than just those actual 10 minutes of the meeting. Okay, aspect number 2, abstraction. Now we are talking about something different. Think back to the previous slide, and on the previous slide I asked you to think about the route you travel frequently. Now I'm asking you a very different question. Describe the route. So for example, imagine that you have a friend who's with you at your work, and you want to explain to them how they get to your home. So you want to give them directions. Sometimes it can be as easy, well, you have GPS in your car, this is the address, put it in. Sometimes if they don't, then they have to explain in more detail. And this is now the question, this is now the game. What are the important things? You cannot tell them too little about the path because they will not be able to find the destination. On the other hand, you also cannot go into too much detail. If you try to explain to somebody like turn-by-turn directions that would be okay for a computer, then you will be giving them a list for 15 minutes and nobody is able to understand it, nobody is able to remember it, nobody is able to follow it, even if they write it down, following it while driving through the city is completely impossible. So you need to find like the correct middle ground, the exact right amount of detail. And doing this is precisely abstraction. We are focusing on what's important. We are abandoning the unnecessary details and just finding the right level of detail that is necessary. And this is very useful also when communicating with each other. And like every profession on earth has its kind of own jargon, own lingo, own set of words and phrases they are using, but the IT is very famous for this, and the IT language is a very, very large set of different labels, metaphors, and names, and so on. So we have all kinds of things like I will store the data in a cloud, I will deploy these virtual machines, and the server will then push the updates to the clients and so on. And none of these things are literal. These are all metaphors, these are all phrases designed exactly with one purpose so that we can easily and quickly communicate large ideas. The server isn't actually physically pushing anything. The server isn't actually doing anything, it's just sitting there. There is a sequence of bytes sent along a cable that does some effect. Well, this is what's happening actually. But we are calling it pushing the update because it gives everybody the right idea about what's going on. And if necessary, we can again go one level of specificity lower and fill in some more details. But usually this level will be sufficient. So the prolific IT jargon is an effect of this, that we are forced to use these abstractions to be able to talk to each other in exactly the right level of detail, not too much, not too little. But abstraction comes to use also when learning how to use tools. And this was the example with the car I gave previously. If you learn how to drive one of the cars, then when you sit in a new car, you can still expect it to look very similar. It may have some features extra, it may be lacking some features, but all of the basic stuff will be there. Sometimes it will look a little bit different, sometimes it will be used a little bit differently, but the major concepts of driving a car remain the same. The same is true with software tools, the same is true if you buy a new cell phone, you switch from iPhones to Androids. Nothing major changes. The phone can still make phone calls and text messages. You can have an internet browser and so on and so forth. You just need to find the right place where it happens, and you can expect all the same functionality. And learning to use a new phone is really easy. And the same thing also happens when we are trying to solve, for example, algorithmic problems. Because when you are analyzing a problem, you also need to be able to make these steps of abstraction. What are the tiny details that don't really matter? What is the big picture that does matter? If you have a problem about several people going from place A to place B and they cannot share the same segment of the path, then you can realize that regardless of what the specifics of how they move are, this is still a general type of problem where we are trying to push as many different units of flow from the source to the sink. So this is some kind of a maximum flow problem, and you can start approaching it as such, finding what the tiny details are, whether or not they change this general concept, and how exactly to adapt the general maximum flow solution to solving this particular problem. So abstraction also an important part of the problem solving process. And step number 3, automatization. So this is connected in some sense to how we learn. This is our nature. By nature, we are all hardwired to learn by practicing and repeating stuff. And this begins when we are born. When we have around 1 year, we start to learn how to walk. And you know how it went because your parents have pictures. They have shown you the pictures, or maybe now also videos. You try to stand up, and then boom, bang, and you fall down. You repeat this 10 times, and on the 11th time, you find the right balance for the center of mass. Then you try to take your first step, and you fall over once again. So stumbles, falls, but by repeating, by practicing, you eventually learned how to walk, and this follows us throughout the entire lives. In primary school, we are learning multiplication tables. First, you have to do it by heart. You have to actually work on memorizing everything. 1 times 3 is 3, 2 times 3 is 6, and so on. And eventually, you can do it without your fingers. You have automatized this knowledge, and you can just apply it when doing some more complicated calculations. Practice when playing sports is obvious. Practice with driving lessons is also quite an important thing, especially if you already know how to drive. You will know that when you take driving lessons, you will learn the basics. At the end, when in your most countries, we take some kind of an exam. When you take the exam, you should be good enough to drive the car if you are 100% focused on driving. What happens next as you are driving more and more is that many of the things you are doing as a driver become more and more automatized. You will get used to, for example, in a manual car, switching gears. You get used to slowing down when getting into a crossroads to just check the situation. You get used to keeping track of other cars that are around you, and so on. And when you become more experienced, you can then, for example, also listen to a podcast while you are driving, make the time more useful, because now many of the things you are doing as a driver are automatized, and now you can spend part of your brain, part of your focus on doing something else, for example, listening to something useful. So this is how we learn. And the main lesson is that when you are practicing, when you are trying to learn how to solve problems, especially algorithmic problems, you should not expect anything different. The only way in which we can learn is by repeating, practicing, stumbling along the way, making the mistakes, and then learning from those mistakes. And this is closely tied to another aspect of automatization, being lazy. And this is something I really love to tell all of my students. A good programmer has to be lazy. And it's not just the kind of never being willing to do anything lazy. The correct kind of lazy is the kind where you really dislike to actually work, but you like to think about working. That's the right kind of lazy. That's what makes the best programmers, software designers, and so on. So imagine there is a problem that you can solve by working for an hour. Some people will elect to just work for the hour and get it done. Other people will spend an hour thinking about how the problem can be done in 5 minutes And in other situations, in our context, these people would maybe spend an hour developing a tool that can solve the problem in 5 minutes. And in life, the first kind of people usually loses, the second kind of people usually wins. Why is this the case? Well, it's because the problems we are solving, they are not isolated. It doesn't happen, or it happens very rarely that there is a problem that is actually unique and that will come up only once. Very similar problems, or maybe different instances of the same problem, will come up again in the future usually. And here comes the difference. If you spend an hour working and manually solving the problem, you will need to spend another hour the next time and the next time. The person who found out how to solve the problem in 5 minutes, the next time a similar problem appears, will solve the problem again in 5 minutes. They saved a lot of time. They can use the saved time to be more efficient, to relax more, and so on. So this is also kind of an automatization, asking in real life, in software development, in computer science, are there things I'm doing repetitively, I'm doing over and over again? And if there are such things in our lives, can we do them better? Can we think about how to automatize this, how to make this more efficient, and spend some one-time investment on optimizing this, and then reap the benefits each time we have to do it in the future? Sometimes it does pay off, sometimes it doesn't. It's a trade-off. We have to analyze it. We have to think about it. So that was the first half of the talk. That was my musings about what it means to think algorithmically. At the end of the talk, depending on how much time we have, I would be glad to talk to you about it some more, to answer questions you might have. So if you have questions about this, you can again put them in the Q&A tab and I will get to them later. Or if you think about some of them later, just feel free to add them at any time. So at the end, we will try to get to your questions for a little bit. Now, I will take 2 breaths, I will take a drink so that my throat gets to relax a little bit, and then I will talk to you about some of the puzzles I like. All right then, so I will introduce you to 2 closely related puzzles that I really enjoyed and I think can illustrate quite nicely the concepts of algorithmic thinking I was talking about in the previous part of the talk. And this is puzzle number 1. I gave this puzzle the title Explorers. Sometimes it's presented under the name Soldiers, especially Soldiers by some specific author. I will mention his name later, but given the current political situation, I really like calling it Explorers, so it's not military. So, Explorers, what do we have? We have an infinite 2-dimensional plane, and in the plane there are some tokens that represent explorers, and we can move them around by doing stuff that's usually done in some solitaire puzzles. Some of the very early puzzles that actually gave us the name solitaire for single-player puzzles that are jumping each other. And so this is what we are doing here as well. Whenever you have 2 of the tokens that are horizontally or vertically adjacent, you can take one of them, jump over the other, and the token that got jumped is then removed from the board. So on the left, you see a situation with 6 tokens, and there is an arrow that's showing for one specific token how it can make 2 consecutive jumps. On the right, there is the situation after the token made those jumps. So the token here is the one that started at the beginning of the arrow, and the 2 tokens that got jumped were removed from the board. And now we are getting to the actual puzzle itself. So in our infinite plane, there are 2 halves. We have a horizontal x-axis. I will show it on the next slide. Below the x-axis is our territory, and the area above the x-axis is completely unknown. Our goal is to place the minimal number of explorers into our half and then use the allowed moves to get as far as possible into the unknown territory. So let's do an example that will clarify what's going on. So the thick line in the middle is the boundary. So before we actually start doing any moves, we have to produce some specific configuration of these explorers. Everybody has to start in the bottom half. And now, once we have the configuration, we can start making jumps. For n equals 1, the goal is get somebody to the first row about the line. And clearly this is not possible if we have just a single explorer because it cannot jump. But if we have two of them, we can place them like this. The bottom one can jump over the top one and get to the first line of the unknown territory. So this is how to explore line number 1. What you need is 2 explorers. This is the optimal solution for line number 2. What you do is you start with the red jump, you get the one explorer on line number 1. Now the jump explorer is no longer there, so now the green jumps are possible. The token that starts at the beginning of the green arrow will make 2 jumps and it will finish on line number 2. So after 3 jumps, 3 tokens have been removed. 1 token is on line number 2 of the board. So now comes the part of the puzzle that will remain for you to solve at home. Your goal is to be solving this puzzle for n equals 3 and n equals 4. So on your own, after the talk, this is quite fun. Try to do it either in a spreadsheet or on paper. Try to simulate the jumps and get a token. So for n equal 3, get some token to line number 3. For n equal 4, get some token to line number 4. And first try to do it, and then if you can already do it, try to do it with as few explorers as possible. So the initial configuration should be as small as possible. Okay, now guessing time. So we saw the optimal solutions for n equal 1 and n equal 2. For 1 you need 2 explorers, for 2 you need 4 explorers. N equals 3, I will tell you that you will need 8 explorers. Now comes the time when everybody at home make a guess what will be the optimum for n equals 4. Yeah, that's right, 20 explorers. Yeah, so the sequence 2 for 8 obviously continues, not 16 but 20. And now comes an even more important guess. So n equals 5. For n equals 5 you will need how many explorers? What is the smallest solution for n equals 5? What do you think? And again, make a guess at home. Is it 40? Is it 100? 1000? Is it even bigger? Okay, we'll see. We'll see in a while. So this is the place where we are now abandoning this puzzle. So keep it in mind. We'll get back to it eventually. We will now switch to a similar puzzle again. We will have a bunch of tokens. We will be doing something different with them. Puzzle number 2 is a puzzle that is called Clearing the Corner. For this puzzle, we now have just the first top quadrant of the grid. And again, there are some tokens. And this time, we are doing something slightly different. So previously, we had tokens that were jumping each other. Now we have tokens that are splitting into 2 new ones. So whenever you have a token like this one with the green arrows, you can imagine that you click on it, and instead of this token, you will get 2 new ones. One of them is on the right, and one of them is above, directly 1 cell to the right and 1 cell above. You can only do this if those 2 cells are both empty. So if you have the token that is currently red, as with the red cross, you cannot click on this one because its right is blocked. But after you do the green move, then you could be able to move the red one as well. And here is the actual puzzle. So these were the rules, how the tokens can move. And now the actual puzzle. At the beginning, you start with just a single token in the bottom left corner, and the goal is to clear as many diagonals as possible. So here's an example how the game can start. Some of the first moves. So we started with one in the corner. We click on it. It is replaced by 2 tokens on the second diagonal. We can click on one of them, and it's replaced on with 2 tokens on the third diagonal. Now you cannot click directly on the token that is still on the second diagonal because it is blocked, but you can click on one of the other ones, and then you can click on the one on the second diagonal, so you get the configuration on picture 5, and there you can again click on one of those. It will be replaced by 2 new ones, so this is configuration number 6, and so on. We keep on clicking, we keep on pushing all of those tokens away from the lower left corner. And the question is, can we get all of the tokens arbitrarily far? Can we clear the area as big as we want, or is there some kind of an inherent limit? And the answer is, start thinking about this puzzle a little differently. Instead of replacing the actual token by 2 identical new tokens, imagine we actually split it in halves. Each time we click on it, we don't just move it, but we also split it in 2 halves. So the top row has the visualization of 2 consecutive moves. The first one is splitting the first token into halves, and the second move is splitting the half into quarters. And now comes the important realization. So if you pick any specific cell in the grid, you can guarantee what size of the token, what fraction of the token will reach this particular cell. This is simply determined by the distance from the origin. If you need 3 steps to get there, in each of those 3 steps you will be divided by half. So for the cell that is on the diagonal number 3, if we start from 0, 0 to 1 to 3, all of those cells will contain either nothing or 1/8 of the token. All of the cells on the next diagonal will contain 1/16 of a token, and so on. And what does this help? How does this help us? This helps us in the following way. Regardless of what moves we do, regardless of the order in which we do them, there is always exactly 1 token. So if we look at the currently occupied set of cells, the sum of the sizes of the individual fractions of the token will always be exactly 1. And now we can look at almost the entire infinite quadrant. We can color everything except for the first 4 diagonals in light green or cyan or whatever the color that is. And now we can compute the sum of all of the weights of all of these cells. And for each row individually, the sum is simply a geometric series. So for example, in the bottommost row, we would have 1/16, 1/32, 1/64, and so on ad infinitum. And the sum of all of this series is 1/8. You have the same in the next 4 rows. And then as you are going higher, you are starting from a smaller and smaller fraction, so the sums start to decrease. So the entire part of the quadrant that is colored has a sum of 3/4, so 0.75. And this means that if you had any sequence of valid moves that would move all of the tokens into the colored area, they would have to have a sum that is strictly smaller than 3/4, because they are occupying a subset of the colored cells. But this is impossible because all of the time the sum of the weights of the occupied cells is exactly 1. You always have 1 token and you are just dividing it into smaller and smaller parts. So what is this telling us is that it's not possible, it is impossible to have the white part completely clear, regardless of how many moves we make, regardless of the order in which we make them. It's never possible to move all of the tokens away from the first 4 diagonals. You can clear the first 3, you can find a sequence of moves that does this, but clearing all of the 4 would require having a sum of weights that is smaller than 1. So even if we had a token, a piece of the token on each and every one of the colored cells, they would still not be enough to assemble together into one single token that we started with. We need to have something left over on some of the white cells. So this is the solution for our puzzle number 2. And now that we made this discovery, and now that we made this observation, we can go back and we can try to do some abstraction. We can try to think about finding patterns between different problems, and we can start asking questions whether we can do some similar argument also in this other game. Can we do some similar assignment of weights? Can we tell that a token that is closer to the goal is more important, bigger, a token that is farther away from the goal is less important? And can we turn this into an argument why something is or isn't possible? And if you now think about the puzzle, I will scroll back to what we had there. If you think about this puzzle, it's kind of backwards from what we are doing. So here in our puzzle number 1, we started with 4 tokens. And if we do everything optimally, we are ending with exactly 1 token on the destination line, right? If we have an optimal starting configuration, there cannot be any tokens left over anywhere, because if they are left over, we can just skip them and not have them in the solution at all. We would have a smaller solution. So we are always ending in having a single token. And now we are doing when we play the same solution backwards, now we are doing something even more similar, because now we are always taking 1 token, and when we are undoing the jump, we are replacing the single token by 2 tokens next to each other. So when we are trying to go back from the final configuration to the initial configuration, we are doing something very similar to the previous task. We are always 1 token is turning into 2. So this gives us some extra hope that the solutions can also be similar. Okay, in chat, Nikita has a comment that this is not a complete solution for puzzle number 2, and that's correct. So my argument was about clearing these many diagonals, and this is the part of the solution I wanted to have to show the similarity. And yes, so it's correct that we can show even stronger results about this problem. We can show that it's, you can tell something more about what is and what isn't possible. And yeah, I'll leave that as an exercise. I just wanted to mention it, that it's correct that you can still make some slightly stronger statement about what is possible in that case. But now let's get back to puzzle number 1. So what do we gain if we are trying to think about this process backwards? In the end, what we want to have is exactly 1 token. This will have weight 1, just as in the previous solution, somewhere on line number 5. And undoing a move splits the token into 2 smaller ones. So what we want to do is assign the weights for the tokens in such a way that what we had before the jump will be equal to what we have after the jump. So the 2 tokens before a jump should have exactly the same weight as 1 token after we make a jump. Okay, this will be slightly more complicated. Why is this the case? Well, because in the previous puzzle, all of the moves were good. All of the moves were pushing tokens away from the corner. In this case, we can be stupid. We can make moves when we are jumping away from the target and just losing equity, moving some of our explorers away from the goal. If we are doing stupid moves, we can expect that the value of the position will actually decrease. So what we will actually have is that the weight will never increase. So if we are making smart moves, the sum of weights will remain the same. If we are making stupid moves, the sum of weights can become smaller. And how will this look like? Yeah, the only final thing we need is to break some arbitrary kind of assignment of weights. It would be nice to have something similar to the previous solution. If the weights are decreasing exponentially, we can then easily sum weights for any single block or some area of cells, because there are some easiest to sum geometric sequences. So the question is, can we make the weights decrease exponentially? And the answer is yes, we can. So it will look as follows. What we do at the beginning, we pick one specific cell in row 5 and say this particular cell is the goal. This is the cell we are trying to reach, and this particular cell will get weight of 1. And now, as we are going farther and farther, we are getting to x squared, x cubed, x to the 4, and so on. So the weight of a cell will be x to some power. The power is the distance from the goal. And now if we are looking at any jump towards the goal, what do you have? So this particular token at the bottom is x to the 7, this one is x to the 6, and this cell is then x to the 5. So what we want to have is x to the 7 plus x to the 6 should be equal to x to the 5. And now we can see that this actually works. Regardless of what the power is, we always get the same equation because we can divide the general equation by x to the n. So we always get the same equation. We should choose x so that x squared plus x equals 1. And this has exactly one positive solution. This is square root of 5 minus 1 divided by 2. This is 0.618 and some smaller digits. And this is exactly 1 over the golden ratio. So it's kind of a reciprocal of the same equation you can encounter by Fibonacci numbers. And is also the reciprocal of the solution for the equation. So 1.618, which is the golden ratio. If you invert it, if you take 1 over the golden ratio, you get 0 point and the same sequence of decimal digits. So that's our value of x. That gives us all of the weights we need. And now we can do the same argument as before. If you have this specific value of x, you can take a look at the entire half plane where we start. Each of the columns is now a geometric series. This one would start at x to the 5, the next one would start x to the 6, x to the 7, and so on. Once we sum all of the columns, we can then do sum of the sums, and we will get an impressive result that the sum of the entire bottom half plane is exactly 1. And what this means is that for n equals 5, there is actually no solution. You can start with 1 billion of explorers placed close together, and regardless of how many you place, regardless of how you jump, the initial configuration will always have sum of weights less than 1 because it's a finite subset of the plane that has sum 1. And therefore, you start with a weight that is less than 1. Your best option is making jumps that preserve the weight, but you can never gain any extra weight. So regardless of how you jump, your total weight will always remain less than 1. You will never be able to reach row number 5. So, as I mentioned in the beginning, this is one of the famous works by John Horton Conway, and it's called Conway's Soldiers in literature. So if you want to look it up on Wikipedia and read more about it, Conway's Soldiers is the name under which you will be able to find this particular puzzle. And again, I will try to give you one extra bit of information about it, one real-life connection if you want. And the real-life connection is that something very similar actually happens when we are trying to do massively parallel computations. And this is something that remains still relatively unknown, and it's not really considered, for example, in the basic theory of parallel computations. The problem here is kind of related to the solutions between n equals 3, n equals 4. For n equals 3, you needed 8 of those explorers. For n equals 4, you needed 20 instead of 16. And kind of the main reason why is that you cannot put 2 explorers into the same cell. And everything around the area when you are trying to enter the opposite territory is already too crowded. So you cannot fit the explorers close enough. And if you are placing them farther, you suddenly need more of them to get them where you needed them. So similar thing happens if we are trying to do parallel computations, because if you physically imagine the hardware that is doing these computations, you cannot assume that all of the communications will be happening in constant time. Why is this the case? Well, because you have one computer here, and now even if you start placing all of the other computers as closely around it as possible, you can only fit a polynomial number of them into a ball of any fixed size. So as you are trying to use more and more computers, the distances between them have to increase. You cannot have everybody adjacent to everybody and send messages in instant time. As you are physically building larger and larger farms of computing, then you will have to deal eventually with the communication speed becoming a factor, and this has then direct implications on the possibility of doing some very fast computations or not doing them in real life models. So a nice puzzle about jumping tokens is surprisingly related to real life applications of trying to solve something with a farm of 100,000 computers. Okay, now we are getting to the final section of the talk. I will give you two more puzzles with no details, just the statements, so that you have something more to think about at home. And then we will get to some very quick Q&A that about stuff you want to ask about this talk. So here's puzzle number one, a very standard puzzle. Can you draw the house? And this is the standard rules. When drawing, you cannot lift the pen from the paper, and you cannot go along the same line twice. So usually we do something like this. We know that this is an Eulerian graph. We are looking for an Euler tour in the graph. We have to start and end in vertices of an odd degree if there are some. So we start at the bottom, we draw the square, then we draw one diagonal, the roof, and the other diagonal, and then we are done. There's one possibility. But now comes an additional rule. So the extra rule is that the line you are drawing is allowed to touch itself. So if you are entering the same vertex multiple times, the line can touch at the vertex, but it's not allowed to intersect itself. So the drawing I was just showing, when you draw the one diagonal and then you draw another diagonal, is not allowed because you are crossing a previously drawn line. So question number one, can you still draw the house? Question number two, can you draw any picture you could draw without the new rules? So if you have any Eulerian graph, can you still draw it in such a way that your drawing never intersects? Either give a proof or give a counterexample. And question number three, can you actually find an efficient algorithm that will produce such a drawing if and only if such a drawing exists? So you will get the graph, and your output should be a description how to draw it so that your path never crosses itself. So that was the puzzle. And now puzzle number four. This is a slightly more complicated puzzle, at least in my opinion. The previous one is easier. So what we have in this puzzle, there is an 8x8 chessboard, so a very standard chessboard. We are not generalizing anything. And we have Alice and we have Bob. Alice has cards that can be placed between cells, and Alice can use these cards to build a maze. The maze has to be connected, but the maze can have loops and such as it's up to her to choose the maze details. So Alice can produce something like the picture shown on the right. Bob has a robot. The robot can be placed onto any cell of the chessboard, and the robot can execute a sequence of commands, and commands are left, right, and forward. Left means that it rotates left by 90 degrees, right means it rotates right, and forward means it tries to make a step forward. If there is an empty space, it makes the step. If there is a wall, then the robot just remains in its current location. And now Alice and Bob are going to treat this as a two-step game. Bob is first, so Bob will enter some specific program into the robot. Bob has to choose one specific program, one specific sequence of instructions left, right, and forward. A finite string of L, R, and F, and enter it into the robot. The robot has a lot of memory. The robot can fit an arbitrarily long string, but the string has to be finite. It cannot be an infinite sequence. The string has to be one specific finite program. And then it's Alice's turn. Alice gets to see the program, examine what Bob programmed, and then Alice can build her maze. The maze must be connected, so all cells must be reachable from each other, but otherwise Alice can choose any maze possible. And the goal of the game, Bob wants to program the robot in such a way that it's guaranteed to visit all of the cells in the maze, and Alice wins if she can break the program, if she can build such a maze, challenge Bob's program, and force the robot to get somewhere in the cycle and never visit one of the cells. And the question is, Which one of them has a winning strategy? Is there a universal program that will solve all possible mazes, or is there, for at least for any program, a strategy how to break the program and force it to not visit one of the cells? So those were two puzzles to ponder at home. If you really get stuck on them and want some questions, then just come to the algorithm section of the Topcoder Discord, ping me, and I'll try to give you more about them. So if you want to ask questions about these puzzles, Discord is the way to do it. And now a final summary. So this is the last slide of the talk. You survived it. Thank you. Congratulations. If you have a problem, what to do with it? This is what we learned. Start by asking the following questions. What exactly is your problem? Do you understand it? Do you understand all details of the problem? Can you describe it to another person? Do actually try doing this. This is closely related to, for example, rubber duck debugging. If you try to explain what your code does to a rubber duck, usually you will find where your mistake lies, simply because when you are forced to actually do the explanation, you are forced to grasp the problem in more detail, more precisely, focus on the details, and often we will realize what you are doing wrong. Once you understand what your problem is, think about, can it be divided into smaller parts? How do those parts interact? Are there some dependencies we have to resolve? And then think about patterns. Think about, what does the problem resemble? Can I identify any patterns? Does it look like similar to other problems I have seen before? Can I generalize the problem, abstract from some useless parts, and focus on the important parts of the problem? And the final thought I want to finish my talk with is that using new algorithmic techniques in algorithm design, this is just a skill like any others, like walking, driving, juggling, whatever. So don't be ashamed if your first attempts don't succeed, if you stumble and fall. It's natural, and it happens to all of us. Even the top competitors who are winning these major competitions, Code Jams, Topcoder Opens, and so on in the world, all of us have been through it. All of us stumble and fall when we are learning new techniques. It's perfectly natural, and it's the only way in which you will learn them. And learning new problem-solving skills begins at the end of your comfort zone. So if you are solving problems you know how to solve, you are still training, you are practicing, for example, your implementation skills, but you are not really practicing your problem-solving skills. You are only practicing your problem-solving skills if the problems you are trying to solve are hard enough to sometimes make you stumble. So that was the last idea. Thank you for joining me today. I had great fun talking to you. Hopefully you liked listening to me. And now is the right time. If you have some questions, we have a few more minutes scheduled for this segment. So let me know what you want to ask, and I'll do my best to answer. Nikita has a question whether I teach algorithms. The answer is currently I used to, or kind of I do, but not so regularly than I did. For many years, I was a professor at the university, so not a full professor, but a slightly lower ranked employee. But I was teaching classes on algorithm design. During the Panettone we had during the last few years around the world, I had to make some different choices. So currently I'm only giving some lectures, usually like on some camps and such, if I'm invited as a lecturer. But yeah, I still do teach algorithms, and I'm working on some stuff that can be published in later years. So expect some more books from me and so on. And yeah, I'm planning to go back to teaching some more at some point in the future, but nothing specific.
I'm sure somebody has questions. Come on, you guys. That was such a great presentation. Thank you, Misaf. That was fantastic. So if you guys have questions, please please add them in there right now.
Yeah, and as I was mentioning, so I'm also on the Top Coder Discord. So if you think of something later, want to ask, just message me there, and I'll do my best to get back to you.
Yeah, awesome. And you're such a great teacher, Misaf. You definitely should continue teaching. I think you're a natural. So thank you.
Thanks. Okay, so Okay, we have one more question, so I'll
Okay.
answer that one, and then we can get back to the actual last item on the agenda, which is announcing the winners of the Humblefool Cup. So the question is whether there are some tips for a newbie to translate real-life situations to mathematical models. And there was an old saying when one of the kings, I don't remember the details right now, but one of the kings asked a question of one of the old Greek mathematicians about learning some concept and whether there is some easier way they can give him specifically as the king. And the answer he got was that there is no royal way to geometry. So there is no royal way to doing this. This is just mostly about getting practice with it. So one of the things I can tell us maybe that may be helpful is just making sure you are getting the details right, because one of the main mistakes I see people making when doing these mathematical models is trying to do it like hand wave it, that it's approximately like this and we will work out the details as we go along. And this is something that sometimes works and sometimes doesn't. And the more complicated your project is, the bigger the chance that you are forgetting something or neglecting to think about something important. So uh, one thing that helps is starting from very small examples and learning, for example, how to implement binary search without having to think about details. Learning to implement binary search correctly at the first try by thinking about those invariants I mentioned, that you have two pointers, left boundary, a right boundary, and you have a binary property that begins as true and at one point switches from being true to being false. And if you think about this and initialize the left pointer to make sure that it's true, the right pointer to make sure that it's false, and then you look into the middle. Now all you have to do is evaluate, is the middle element still true or is it already false? And this tells you which pointer to move to the center. And if you think about the problem in this way, there are no corner cases anymore. There are no details to be left to work out, but you have an exactly right invariant in mind. You have exactly grasped the property you needed, and you have the model of the situation. So once you learn how to do this on small playground examples, and this is why we are using binary search as one of the tools in education, something that will be present on many different algorithm lectures. Once you learn to do this in these small toy problems, then it becomes easier to do similar things with more complicated real life concepts. You will get better at being able to realize what are the important parts, what you need to focus on, and what are the parts that can be abstracted away, what are the parts that can actually be ignored when doing this mathematical modeling. So yeah, the main answer is practice, and the sub answer is when practicing, start small.
Great answer. Great question. Thank you. So thank you again, Misaf, for being here. We really appreciate all your learning. So thank you for everything. And
Thank you,
we'll have
everybody.
to get
Pleasure
you on
being here.
again.
Congratulations in advance to the winners, and see you some next time. Bye.
Yeah, we'll have to get you on again soon. Thanks. All right, you guys, who's ready for some winners? Excited to announce some of our Humblefool Cup results. So I'm super excited about that. And hopefully you guys got some great learnings today from all of our speakers. So thank you for being here. Okay, I'm going to bring up the results that I have learned. So we are going to be announcing our Humblefool Cup results. So we had a qualification round and we had a final round. So we need to see who's winning and what they are winning, okay? So first up, we have from the qualification round, our first place winner was Geothermal. So congratulations to you, Geothermal. That is $100 for you. Fantastic. All right. And then moving on to our final round, final results. That was just a couple hours ago. Misaf was the problem writer and coordinator of this round, and Aaron was the administrator. So thank you to Aaron and Misaf for that. So our fifth place winner is Durup HP, $25. Congratulations for winning fifth place. And the results are not final in the arena yet, but we will be loading those in after we make these announcements. So in case you want to go back and check out some more of the results details. Fourth place, we have Nevermore 2002. So congratulations to Nevermore 2002. $50 for you for winning fourth place. In third place, we have Cal013 winning $75. So congratulations to you. Well done. In second place, we have Srikanth.R winning $150. That'll buy a lot of books for you at school, right? That's what you're going to spend your $150 on, books, right? All right, and our first place champion of the Humblefool Cup 2022 is, drumroll, Hate Walking. Well, now you don't have to walk because you have $350. You can get an Uber, right? Pay a cab. Congratulations in first place to Hate Walking. So amazing job to all of you. Congratulations. I hope you enjoyed the Humblefool Cup and this event today. We are ending a little early, which is fine. I can open up a lounge if you guys want to hang out for a little bit. So again, I just wanted to say another thank you to Triple IT and Aparoksha for participating with our event here today and running this event and then helping us to do this Humblefool Cup for our 6th year. It's a great honor to be able to continue to honor Humblefool. And as I said, if you're just joining and you haven't heard of him, go Google Humblefool from India and you'll see what an amazing guy he was. Thank you again to our AMA competitors, Jonathan Irvings, PJ Mathematician, and Skynick. We really appreciate you coming here and sharing your insight with everybody and chatting with us. And then, of course, thank you again to Misaf for his amazing chat today where we could learn some things. So thank you again for being here. I really hope that you enjoyed our event. We will do more of these if you like them. So thank you again. Have a great rest of your weekend, your weekend, all that good stuff. And we'll see you again soon. So thank you, folks.